Bob Aviation 360's document scanner uses the same AI brain that powers Google's image search. We just taught it to read boarding passes instead of finding cat photos.
That's incredible. So we're basically leveraging Google's billion-dollar AI and customizing it for our needs.
Prepare to discover how pre-trained models and transfer learning let companies like Aviation 360 build world-class AI systems in weeks instead of years. This approach is revolutionary, but it creates unique testing challenges you need to understand. Note before we continue, behind every episode is a full week of work, digging into the syllabus, building Aviation 360 examples, and cutting the script. Hours of video editing until it's clear and useful.
If this saves you time on the job, a subscribe tells us to keep going and helps this reach more testers.
Thanks for supporting thoughtful, no-fluff training. Now let's get back to the lesson. Bob, remember when we needed our luggage scanner to identify damaged bags? Training an image recognition system from scratch would require millions of luggage photos and months of processing time.
That sounds like a massive undertaking. How did we get it working so quickly?
Here's what's fascinating. Instead of starting from zero, we took Google's ImageNet model that already knows how to identify 1,000 different objects, and we just taught the final layers to recognize luggage damage patterns.
Wait, so we're using Google's pre-built AI brain and just changing how it thinks about luggage?
Exactly. But this approach creates some unexpected risks that most companies never consider. According to I.S.T.Q.B, pre-trained models are AI systems already trained on massive datasets, like ImageNet's 14 million images. Instead of building from scratch, we use transfer learning to adapt these models for our specific needs.
How does transfer learning actually work?
Think of it like using a brilliant medical student who already knows anatomy and just teaching them aviation medicine. Our document scanner uses B.E.R.T, Google's language model trained on billions of web pages, but we fine-tune just the final layers to understand airline terminology.
This seems like an incredible shortcut. What are the risks you mentioned?
Here's the shocking part. We inherit all the biases and vulnerabilities of the original model. If Google's ImageNet has problems recognizing faces of certain ethnicities, our security system inherits those same biases automatically. Plus, I.S.T.Q.B warns that we often don't know what data was used to train the original model.
So we're getting powerful AI capabilities, but also unknown problems.
Precisely. The I.S.T.Q.B emphasizes transparency issues. We often can't see exactly what the pre-trained model learned. Our passenger sentiment analyzer inherited B.E.R.T's language understanding, but we discovered it struggled with aviation-specific slang that wasn't in Google's training data.
And we can't fix those underlying issues.
That's the challenge. If the pre-trained model has architectural limitations, we're stuck with them. Here's something critical. If attackers know we're using specific pre-trained models like ImageNet or B.E.R.T, they might already know our vulnerabilities. I.S.T.Q.B emphasizes that shortcomings of pre-trained models are likely to be inherited, and vulnerabilities associated with known models may already be documented by potential attackers.
How do we test systems built with pre-trained models?
It's completely different from traditional testing. We can't test the pre-trained layers, they're frozen and unchangeable. Instead, we test the transfer learning effectiveness and verify that the model performs well on aviation-specific data. Critically, we design tests to detect potential inherited vulnerabilities, especially because the models we use are widely known.
What about those unknown vulnerabilities?
That's the testing gap we must address. We test extensively with our aviation data, but we can't fully predict what edge cases might trigger inherited problems from the original model. Our baggage scanner works perfectly on modern luggage, but struggles with vintage suitcases. Because ImageNet had limited historical luggage data, we also verify our system for any biases inherited from the pre-trained model, like potential facial recognition issues.
This makes AI testing much more complex than I realized.
Next episode, we're exploring AI risks, regulations, and standards, the legal and ethical framework governing intelligent systems. Understanding compliance is crucial for avoiding regulatory penalties and liability.
After learning about hidden inherited risks, I'm really interested in how regulations protect against these problems.
The regulatory landscape will transform your understanding of AI requirements. Subscribe to Testtactix for the complete I.S.T.Q.B. C.T AI certification journey. We're building comprehensive expertise.